Okay. So a thin plate of irregular shape is suspended freely by cord from a point A as shown in figure 1. Next, the plate is suspended freely from another point B as shown in figure 2. The center of gravity of the plate is most likely to be found at. Okay, drop your answers in the chat box. I got the answer from Zufar. Yes, I think your answer is correct. Answer correct from Hirosh, I got it. Okay. What about Abhishani? What is your answer? Abhishani, you got an answer? Okay, so here, according to figure 2, we can see that center of gravity should lie on this line, in this vertical line. Okay, so it could be either P, Q, R, or S. So therefore, the center of gravity should be either P, R, or S. And then when we hang it from A, so you can see from A to A2, therefore I have to draw a line. Where is this subject? Okay, so here is A and A2. If I draw it like going through R. So therefore the point is R. So therefore the center of gravity is okay. And the next question. Okay. The diagram given a cross section of a toy placed in horizontal table which always returns to the upright vertical position when released. The center of gravity of this toy most likely to be at. Okay, drop your answers. Okay, so here now this one is also a part which related to the next one that we want to discuss, the stability of an object considering the center of gravity. Okay, so here it says it always returns to the upright vertical position. Therefore, it cannot be point A or B. Okay, so there B means it always stays in the same uh, place because it's a neutral equilibrium. We will discuss soon what is neutral equilibrium means and stable equilibrium and unstable equilibrium. So this one should have a stable equilibrium. Therefore, it can be either C, D, or E, but E is practically not possible. Practically, E is not possible. That means the mass at point E should be very, very large compared to other all point. So therefore, E is practically impossible. So either C or D. So therefore, we can take which always returns to upright vertical position when released. So therefore, we can consider as point D will be more stable one. So we can take D as the answer. Okay. Okay, and then question number 4. A person bends over and touches his toes as shown in the figure. The center of gravity of the person is most likely found at. Okay, so far your answer is correct. Good. Hirosh. E. B. Okay. Yes. Yeah. So the center of gravity will be B. Okay. So we had to consider the mass distribution, right? So it will be point B. Okay. Question number 5. Okay. The coordinates of the center of gravity of a uniform sheet cardboard shown in figure A are x naught, y naught. The cardboard is now folded along OP as shown in figure. The center of gravity of the folded cardboard has coordinates x, y, where? Okay. Uh, did you get the answer? Please any message put to the TKI so it will be easy for me to view. Okay. All right. So here, if you consider this one, like for example, if you have square cardboard, okay, then we know the center of gravity will be at the midpoint of this cardboard, somewhere here, middle point. Since now we cut and take this point out, it will be shifted somewhere here. Therefore, the center of gravity of this cardboard will be somewhere here. Okay, be much somewhere here. Okay. Okay. So now this cardboard is folded like this. So since the cardboard is uniform, after folding also the same uniform distribution will be there. Okay, so therefore now I can divide into a dotted line like here. So now this one is large, I mean rectangle and triangle. So here and here, so the center of gravity will be now here. Okay. It would be close to this one because this is larger. So therefore, x is greater than x naught, and then y is less than y naught. X is greater than x naught, y is less than y naught. So answer is fourth one. Okay, because since you fold this, the mass distribution of in the y direction decreases. Okay, so in the mass distribution in y direction decreases, meaning that y coordinate will decrease, and then the x coordinate will increase. Therefore, x has to increase. Okay, so therefore answer is the fourth one. Okay. And do the question number 6. Okay, when a H-shaped body shown in the figure is hung from point B, it hangs with point D directly below B. When the body is hung from E, it hangs so that the point C directly below E. Okay. The center of gravity of the body is more likely to be at. Okay. Put your answers. X naught, Y naught is the center of gravity of this object. I mean, this cardboard, right? In this, the cardboard is not folded. Okay, so its center of gravity will be here at this point. Okay, and then after folding it, the center of gravity is changed to here. Okay, so then X coordinate will be less than greater than X naught, and Y coordinate will be less than Y naught. X naught, Y naught is this value. So X naught, Y naught is here, and then you want to write the relation between X, Y, and X naught and Y naught. So it's like this. So here the X naught, Y naught coordinate will be there, X naught comma Y naught. X naught comma Y naught. So relative to this point, now the new center of gravity will be here, which has coordinate X comma Y. So you have to write the relationship between X and X naught, Y and Y naught. So here X is greater than X naught, Y is less than Y naught. Okay. Okay, what is the answer for the next question? Question number 6. Okay, so your answers are correct. It is S. Because when you hang it from E, C will be at the bottom. So it's S is the correct answer. Okay, and do question number 7. Can do question number 7. Okay, drop your answers in the chat box. Christopher, did you get the answer? Okay, so your answers are correct. Okay, let me explain. Give me this pen. Okay, so here in the H2O molecule, we know the masses of hydrogen and oxygen. Hydrogen is 1, oxygen is 16, right? The mass number. So here 1 and this is 1, and therefore the mass of here will be center of gravity of this hydrogen and hydrogen will be 2 here, and this here oxygen is 16. So the center of mass of this 16 and 2 is like the ratio 8 to 1. 16 divided by 2, so 8 to 1. So the ratio 8 to 1, if I consider, it will be the most probable one, because we can't take T also. To take T, the mass of the oxygen has to be very, very large compared to hydrogens, right? So therefore, most likely to be at S. The answer is S. No, I didn't type anything actually. All right. Okay, question number 8. Let's do up to question number 9 and then let's start the class. A uniform wire is bent as shown in the figure. The center of gravity of the whole wire is most likely to be at. I think here there is a mistake again in this figure. It has to be same length. Right? L should be the same length. Here L. Okay, and then L length. Again, same length here should be the. It's appear to be half a length, but it's actually L length. L. L. Okay, so the shape should be like this, but I think they have mistakenly drawn this and making typing. Yeah. So in A, B, C, D will be like that. B, C, D, E. Okay, so what is the answer? Okay, Hirosh and Abhushan. Okay, I got the same answer from each of you. Let me check. Okay, so here what you can do is here the mass is m. For example, let's say m. and here the mass is m, and this part has mass m, and this one center of gravity here mass is m and m. So then here, if I consider the center of gravity of these three mass, and so we form a triangle, so it will be somewhere here. Okay, center of mass of these three will be here, so more like in P, and then that point mass is 3m actually, and then these two mass, center of mass is here, so it will be 2m. So therefore the ratio should be 2 to 3. So therefore it has to be close to this point. So thinking that C is the correct one. Yes, C is correct. Okay, and question number 9. Okay, I'm getting two different answers. Let's see which one is correct. The object in the shape shown is cut from a uniform sheet of metal. Uniform sheet of metal. The center of gravity of the object is most likely to find that. Okay, so here again, what I can do is here the center of mass of A. So each this part, let's take the mass is m. Okay, so a square area has a mass of m. So therefore the mass of A will be 4m. So this one has center of mass of this part has a mass, center of mass is here, and 4m. Okay, since we are talking about take the objects in uniform gravitational field instead of center of gravity, I can discuss with the center of mass, because in uniform field center of gravity and center of mass coincide. So here this part, if I take, its center of mass will be at point A, and it has a value, the mass is 4m, because each square shape has 2m, and point D is the center of mass of this rectangle, it is 2m, and point C is the center of mass of this rectangle, so it has a mass of 2m. Okay, so now I want to find the center of mass of uh, the entire sheet. So here, if I consider the center of mass of these two, D and C, I mean here 2m and 2m, so it will be here in the straight line. On the straight line, it's connecting on it, C and D at the midpoint, whereas two mass are same. So the center of mass will be here, so it will be 4m. So then we want to find the center of mass of the entire thing, so we can connect these two lines. So it's the midpoint, the center of mass or the center of gravity of the whole object will be. So point P is the answer. P is the correct answer. Okay, so then let's move on to the theory. Okay, so we want to discuss about stability and center of gravity. Okay, now there are three types of equilibrium states. There are three types of states of equilibrium. So you can write some topic, states of equilibrium. States of equilibrium. Okay, so the first one is stable equilibrium. Stable equilibrium. Second one, unstable equilibrium. And third one is neutral equilibrium. Okay, I can explain you each of these with an example. Okay, so here stable equilibrium definition: if an object returns to its original position after being tilted, after give a small displacement, if it comes to the same position, means it's a stable equilibrium. Okay, an unstable equilibrium means if you give a small displacement, okay, slightly if you tilt it, the equilibrium breaks, so it's unstable equilibrium. Neutral equilibrium means whatever the displacement or positions you make, the object will remains equilibrium. Okay, so I can explain you that with this example. Yeah. Okay. So let's say I have a bottle that is placed here and placed here and one placed here. Okay. And I say this point is A and this is B and this is C. Okay. Out of these 3 points, which point is stable? A or B or C? Out of these 3 points, which point is stable? A or B or C? Okay, so here the stable one is B. B is the stable equilibrium. Stable equilibrium. Because if you give a small displacement, it will again come back to the same position. For example, if you take this ball and leave it here, what happens? It will oscillate, and then due to the resistance and friction, the energy loses and finally come to the point B. So point B is stable equilibrium. Okay. And point C is very clear, it will be unstable. If you give a small displacement, it will accelerate, right? So the equilibrium breaks, so unstable. And if you take this ball and give a small displacement, keep here or here, whatever the place if you keep will be at that place. So it's a neutral equilibrium. So this is neutral. So you can, after writing this, here you can write what is stable equilibrium means. if an object returns to its original position after being tilted or given a small displacement or given a small displacement or given a small displacement yeah. So actually let's write down stable equilibrium. Write down. I give the not because it's not so accurate. This actually writes the equilibrium states only for the solid objects, like regards to the center of gravity. But we had to speak in general. That means this description is given only regards to the center of gravity. So you write down this stable equilibrium if an object returns to its original position after being tilted or given a small displacement. That's all. And unstable if an object topples after being slightly tilted. No, we can write like this. When object tilted or given a small displacement, its equilibrium breaks and starts to accelerate. That is unstable equilibrium. If the object is slightly tilted or given a small displacement, its equilibrium breaks and starts accelerating. So neutral equilibrium means after giving a small displacement, it is neither come to the original place nor accelerate. It is neither comes to the original place nor accelerate. It will be remains equilibrium in that new position. That is neutral equilibrium. Yeah, sure. I'll repeat. Yeah, I will explain what is center of gravity, low and high. Okay. Stable equilibrium. If an object is slightly tilted or given a small displacement, it will come back to its original place. Okay. So object will returns to the original position. So that is stable equilibrium. Unstable equilibrium means if you give a small, if you take the object and tilt it slightly or given a small displacement. And neutral equilibrium means if you tilt the object or give a small displacement, it will neither comes to the original place nor accelerate. It will be remains equilibrium in the new position. So that is neutral equilibrium. In neutral equilibrium, when object given, if you give, when the object is slightly tilted or given a small displacement, it will neither comes to the original place, no accelerate. So those things won't happen. Rather, it will be in equilibrium in the new position. That is neutral equilibrium. So the example you can write this. So this is the best example that you can understand. So here this is neutral equilibrium. This is stable. It always comes to this point. And here is unstable. If a slight displacement is given, it will be break the equilibrium and start accelerating. So write down that example. Okay. And the factors affecting the center of gravity of solid objects or objects: shape, and then weight distribution and density. Okay. Or here you can write mass distribution. Okay. Right. Let's do this question. So you can do this. Find the center of gravity of these two masses. Okay, anyone finish this question? Okay, what's the answer? You can just tell me the x value. The x value, yeah. Okay, let me check. So here, find the center of gravity of two masses. M1 equals 5 kilogram and M2 equals 3 kilogram based on straight line. At positions x1 equals 0 and x2 equals 4 meter. So here the x-axis, this is 5 kilogram here 0 coordinate, the x is measured in meters, is 4, and this mass is 3 kilogram. So its center of mass or center of gravity will be at the midpoint. Okay. So now we want to find the center of gravity of these two masses. So the theorem is, we know x equals sigma mi xi over sigma mi. So therefore, I'm taking the moment from here, so it will be easy for me. So that this mass also cancels, right? So therefore, x equals, straight away I'm taking from here. So you can write x equals to MIXI, 5 kilogram into 0 plus 3 kilogram to 4 divided by total mass 5 plus 3, 8. So x equals 3 into 4, 12. 3 into 4 divided by 8 is 2 into 4. 4 and 4 cancel, 1.5 meters. So 4 meter here, 2 meter. So here 1 meter. So half of that here will be the center of mass. See. Okay. Okay, I think the answer is given here. Yeah. Okay. So now we'll do a small discussion on the. So Hiroshi asked me what is high low in center of gravity. Okay. So now, for example, if I take object, the object stability depends on the position of center of gravity. Okay. If the center of gravity is high, means it has a low stability. If the center of gravity is low, means it has a good stability. Now, okay, imagine you have an object like this. Okay. Okay. So if the center of gravity is high, let's say somewhere here. So wait, let's say this is the object, and the center of gravity is high somewhere here. So then if I tilt this object, okay, I take the same object. Okay, so here I can't, the rotating option is not there in the zoom. Let's okay, give me a second. I'll try this. So this has rotating option. So let's say we have object. happening. Give me a second, guys. Okay, so here is the object, and let's say its center of gravity is high. Okay, somewhere there. Okay. So here's the center of gravity, G. Okay, now I'll take the same object and I'm going to tilt it. So this is the ground. Okay. So here the center of gravity is high. Okay, and then I take another object where it has a lower center of gravity. So this one has, let's say, low center of gravity. I can say a little bit narrower as well. And say center of gravity is here. And then I tilt this object. Okay, so here now, here the weight is vertically downward. And then here normal reaction force upward. So that we know those are then initially mg are equal balance. Okay, so here in this one, here the R. Okay. And here this one, if you consider its weight vertically downwards. Mg. Okay. Now if I tilt this, So there will be a, now from this point there will be a movement, so this will topple. Now here in this case is the R, and G is here. Excuse me, I'm new to this app. Okay, so here G. Okay, now here what? Now here it has a large, the center of gravity is high. Okay, so in this case, even if you slightly tilt, you can see there is an unbalance, so this one will topple. Okay, but here there will be a torque in this direction, right? Because this is here and this here, the torque will be anti-clockwise. So this makes the object again comes to the stable position. So when object have lower center of gravity, it is stable. So this is stable equilibrium. Stable, and this is unstable. Okay. Did you understand, Hirosh? I wish one day I could make the animation like how the gravity, center of gravity, and the weight changes with the angle. So that way I can explain easily. Anyway, that I hope you understood. Let me know in chat box whether you understood. For circle, okay, so like sphere. If you take a sphere, it's if the mass distribution is uniform, then its center of gravity will coincide with center of mass, and it's coincide with geometric center, the center point. Therefore, a sphere has a neutral equilibrium. It's a neutral equilibrium. So whatever the location you keep, it will be stable there. Okay. So sphere has a neutral equilibrium. In Combinax, you will study about that much deeply. Like for example, objects like this. Wait, I'll show you here. The question we did. Yeah, for such a solid, you will discuss. Not forget about this phase. Okay, where is that phase? So as I told you, you have in Combinax, you have center of gravity lesson. There you study this stable equilibrium and all, right? Now, for example, let's say the object has some mass distribution, okay, and its center of gravity will be, let's say, let me explain, hold on. Okay, so suppose its center of gravity is somewhere in A. It is unstable. If it's point like A unstable, C and D are stable. Stable because it again comes to the original question. There is a toy. I mean, this question was about that toy. If you tilt, it will come back to that the same place. It's like a balloon. At the bottom part, there is a small pocket. They filled sand, so they are heavy at the bottom. So even you tilt, it will come back to its the vertical shape. But if the center of gravity is B, it is neutral because the whatever the place that you keep, it will be balanced. The point B is neutral here. Okay. Now, for example, if you have seen your water bottles, sorry, not water bottles, the water glass. At the glass, they don't make the glass like this shape. The glass are not like this. Rather, it has something like this, and at the bottom they have something glass weight. This is how the glass, the drinking water glass is there because to lower the center of gravity. If they made the glass like this, so center of gravity is here, so high chance of toppling. To minimize the chance of toppling and breaking, so they make the bottom very heavier, the water glasses. Okay, and also that the cars that you have seen in racing track, Formula One cars and all, they are like very flat in the size of the wheels actually, right? Because to make the center of gravity lower, so it will be more stable. Understood? So those racing cars all have lower center of gravity. Now, for example, I don't want to go much deeper. I mean, in wearing my hand, now I have this object, my pen holder. So this pen holder has a low center of gravity. Okay. So here, without the pen, now this, if I take this bottom part is weight. It has made of covering is plastic, but inside metal part is there. This side is, so I can make it to large angle, so it will always fall like this. So here the angle, see how much of angle I'm tilting. Again, it falls to the same side. Okay, so you can see the angle, how much I have bent it. Again, it falling to this that side only. It's not for after this value only, it's falling in. But you can see still I can make able to make this much of angle because this one has lower center of gravity. They have designed like that so that when I'm holding this pen, there less chance of toppling. Give me a second, guys. Okay. Yeah. So I was talking about this one. Yeah. So this one is made in a special way so that when I got like there's less chance of last. Sorry. So this one has made in that special way, so it has less chance of turbulence. Right. Yeah. So the stability of an object depends on the position of the center of gravity. Okay. Right. should go there. So then that's all about the stability of center of gravity. How do I clear this? Okay, so with that, I think the notes on center of gravity is over. So you can do more questions on center of gravity, like if you have a mass distribution, find the center of gravity of it, or you have sheets and then you want to find the center of gravity where it most likely to be, and that type of question. And also like combined objects, like you have a cylinder and then semi sphere. If they combine two, then where is the uh, center of gravity more likely to be? And then, for example, if you have a rectangle and then semicircle of shape is uh, cut and removed, then where will be the center of gravity? So those type of questions and all you had to do it and practice. Okay, I think with that we are done with center of gravity theory. So the next topic that we have to move is force equilibrium. So that's our next topic, force equilibrium. So I will start that in our next class. Alright. So that would be our next topic, the force equilibrium. And in mechanics, we have to discuss more lessons. I can show you the remaining chapters we had discussed. So vectors, we are done. And then kinematics over, force and Newton's laws over, momentum collision finish. So we have done up to here. Okay, so we have force equilibrium. So force equilibrium we can finish in one class. And then work energy and power. So out of these, the work energy and power and hydrostatistics are a little bit big. And then the rotation motion and circular motion, we can finish it. I think by the end of January, we can finish the mechanics. Before, yeah, January last week, we can finish the mechanics. And then we have to do this measurements part. So I'm planning to So I had to do it on December. So I'm arranging the notes and all, and hopefully want to do practically. That's what much beneficial. I will update you by next week. What we shall do about regarding that. Okay. Okay. So if I can, I mean, I think most of you have the school holidays like that, right? So if I can put a, I mean, if I schedule extra class, will you or be able to come? Like the extra class for the measurement part. So we have 4 measuring instruments and also this type of errors, and then uh, yeah, basically the type of errors and the measuring instruments. So types of errors, I think you might, I hope you have already got the note, and the parallax error, systematic error, and the fractional error, percentage error, and zero error in measuring instruments. No, actually, I'm planning to do 2 days. So one day I'll be doing all the theory part, and then another day we can do practical sessions. So yeah, Friday I have all day classes. Um, it can be either Tuesday or I will drop a message in the group so that you all can respond, and based on the votes, we will see what we can do. Okay. Okay. And then very important thing is you need to do questions from what you have studied up to now, like unit 1, vectors, kinematics, and everything. You have to do questions. And if there's anything you find difficult, you share that question to me so that we can discuss in the class. Okay. And also, yeah, the paper class being started, but I recommend only Hirosh. He already joined there, but others can start after uh, we've finished the kinematics, because still I think for Abhishani and Zufar I have done unit 1 not fully covered. So therefore, maybe you all can join the paper class from January. Okay, then. So that's all for today. If you have any questions, you may ask. Okay, so in our next class, we will start the force equilibrium. It can be done within, the theory is only few. I mean, almost half the theory I have discussed today also. So we will do in our next class the theory of force equilibrium and some questions based on. Okay, then, good night. See you. Take care.